Hi, let's start our first lesson. In this series of video, I will teach about the basic math scale for secondary school students. Okay, so in lesson number 1, I will share with you like terms and unlike terms. What is like terms? Okay, it's actually very simple. For like terms, they need to fulfill these two conditions. The first one, same variable. And the second condition, the power of each variable are the same. Same power of each variable. What do I mean by this? Now let's look at a few examples so that you can understand it better. 3xy squared and negative 5xy. To determine whether the two algebraic terms are like terms or unlike terms, we don't have to focus on the coefficient. We only focus on the variable part. This is the part determine whether two algebraic terms are like terms or unlike terms. Now remember two things, same variable and the power of each variable are the same. Now you'll notice that the variable here are x and y, the variable here also x and y, but you will notice that the power of y here is 2, but the power of y here is 1. Different power, right? Therefore, we can make a conclusion that these two are unlike terms. Unlike terms. Now, how about this? 1 over 2 x, y, and negative 3x squared y. Again, we only focus on the variable part. Now you'll notice that the variables are the same. This is x and y, here also x and y, but the power of x is 1, the power of x is 2, different power. Therefore, these two also unlike terms. Now, let's try one more. How about 6x squared y power 3 and negative 4 over 5 x squared y power 3. They're having the same variable, which are x and y also. And then you will notice that the power of x is 2, the power of x here also 2. The power of y here is 3, the power of y here also 3. Therefore, we can make a conclusion that these two terms are like terms. Why is that so important to know whether the two given terms are like terms or unlike terms? Because only like terms we can perform additions or subtraction. For unlike term, we cannot perform addition or subtraction. Now let's go through these few examples, these few questions, so that you understand better how do we determine whether the two given algebraic terms are like terms or unlike terms, and how do we perform addition, subtraction, multiplication, and division among algebraic terms. Now let's look at the first one, 2x and 3x. Like terms or unlike terms? Like terms, right? This is like terms. For like terms, we can perform additions, subtraction, multiplication, and division. Now let's look at A. 2x plus 3x. So we have 5x. How about subtractions? 2x minus 3x. 2 minus 3, you will get negative 1. So the x we only copy, but you don't have to write negative 1x. You can just write, in this situation, if you get negative 1x, we only write negative x. Okay, so you will notice that for addition or subtraction, the power of the variable will remain unchanged, right? So how about multiplication? 2x times 3x. So 2 times 3, you will get 6. X times x, you will get x squared. You notice that? Now, the power of the variable already changed from 1 to 2. Division. 2x divided by 3x. So you can change the way of writing it, become like this: 2x divided by 3x. Now you can simplify it this way. So the answer will be 2 over 3. Before I show you the second question, let's do a quick revision for this one first. Now, if let's say you have x times x power 3, what is the answer? X power 4. How do we get 4? 1 plus 3, right? 1. If you don't see any power here, it means power 1. So why do we find the sum of the two power? It becomes x power 4. You can think this way. If you don't understand this, let me explain it this way. Now this x is equal to x, right? And the multiplication sign, I just copy. This x cubed, it means x times x times x. Now, eventually, how many times of x? 4 times, right? How do we get 4? 1, 2, 3, 4. It's actually 1 plus 3, right? So when you have multiplication and the base here are the same, you can just find the sum, the power of the answer is the sum of the two power here. Okay, let me give you one more example. Let's say 2x power 3 times 4x power 5. What is the answer? 2 times 4, you will get 8. X power 2 raised to the power of 8. How do I get 8? 3 plus 5. Okay, now how about division? If let's say you have x power 3 divided by x, you can do it this way. Always cut the variable with a lower power. In this situation, this is power 1, this is power 3, right? So you can simplify this way, cut this one, and 3 minus 1, because the power here is 1. 3 minus 1, you get 2. So the answer will become x power 2. And why do we do so? X times x times x. This is x power 3, right? X. So now you can actually simplify this way, right? Eventually you get the same answer, which is x power 2. 3x, 3x times x times x 3 times, and you cancel one. You cancel one of the x with this one. You simplify that. This is why we can do it this way. So another way to do it is you can do it this way as well. 3 minus y. 3 minus 1. The same theory. X squared. So why we take 3 minus 1? Because this is x times x times x. And this is 1 times of x. Cancel, right? 3 times you cancel 1. You take 1 of the x, simplify with the denominator. So eventually you left 2 times. That's why it's x power 2. Okay, and one more thing you need to understand. How about x squared divided by x power 5? Now, as I told just now, you can cut the variable with the lower power. So in this situation, it's power 2, lower power. And 5 minus 2, you get 3. So the answer is 1 over x cubed. Remember, 1 over x cubed, not x cubed. Okay, so if you don't understand this, you can do it this way as well. X times x. This is x times x times x 5 times. Now you simplify it, right? X cubed, 1 over x cubed. Another way to solve it, for division, we can just minus, find the difference between these two powers. So 2 minus 5, which is equal to negative 3. So you might be thinking, teacher, this is x power negative 3. This is 1 over x cubed. Are they the same? Yes, they are the same. X power negative 3 is actually means 1 over x cubed. You can try to press your calculator. 6 power negative 2 and 1 over 6 power 2. They are the same thing. Now, 6 power negative 2, 1 over 36, right? 1 over 6 power 2, 1 over 36 as well. Okay. Now let's proceed to the second questions. Negative 5xy squared and 3xy squared. Are these two terms like terms? X, y squared, x, y squared. Yes, they are like terms. Negative 5xy squared plus 3xy squared. So negative 5 plus 3, you will get negative 2. If you want to show the step, you actually can do it this way, but normally we do not do it this way. Negative 5 plus 3, and then you just copy the variable xy squared. You will get negative 2xy squared. So how about B? Minus negative 5xy squared minus 3xy squared. Again, you can go straight to the answer, which is negative 8xy squared. How do I get negative 8? Negative 5 minus 3. So if you want to show one more step, you can do it this way. Negative 5 minus 3. And for the variable part, you just copy. The power of each variable remain unchanged. Negative 8xy squared. Okay. This is addition and subtraction. Now let's go to multiplication. Negative 5xy squared times multiplied by 3xy squared. Okay, how do we get the answer? Negative 5 times 3, you will get negative 15. X power 1 times x power 1, you will get x power 2. How do I get 2? 1 plus 1. Y power 2 times y power 2, you will get y power 4. How do I get 4? 2 plus 2. Now let's go to D. Negative 5xy squared divided by 3xy squared. So if you look at this, will make you confused, you can change the way of writing it become like this. Negative 5xy squared divided over 3xy squared. They are actually the same thing. Now the negative 5 and 3, we cannot do anything. We just copy negative 5 over 3. And the x here, x power 1, x power 1, you can simplify them this way. Y power 2, simplify this way. Eventually, the answer is negative 5 over 3. Now let's try question number 3. Question number 3. This is 5pq squared and 2kq squared. Are these two like terms? No, unlike terms. One or y unlike terms, their variable are different. This is p and q. The variable for this term p and q. The variable for this term is k and q. So different, right? Different variable. Therefore, these two are unlike terms. For unlike terms, we cannot perform the addition, also subtraction. So we only can do multiplication and division. 5pq squared times 2kq squared. So 5 times 2, you will get 10. And p times k, we cannot do anything. I just write k followed by q. Oh, sorry. P times k, kp. K times p, okay, kp. Q squared times q squared, you will get q power 4. Okay, so how about the division. 5pq squared divided by 2kq squared. So again, if you're not familiar with this, you can change it become this. 5pq squared over 2kq squared. So 5 over 2, you don't have to change it become 2.5. You just copy 5 over 2 is okay. P over k, we cannot do anything. For the p and k, we cannot do anything. We'll just copy p and k. And the q, this is q squared, this is q squared. We can simplify that. So no more q. So this is the final answer. Let's try question number 4. These two like terms, x squared, y, z power 3, z power 3. Yes, they are like terms. So for like terms, we can perform addition, subtraction, multiplication, and division. Negative 2 over 5 x squared y z cubed plus x squared y z cubed. So if you don't see any coefficient here, it means 1. So how do we get the answer here? You can just press your calculator, negative 2 over 5 plus 1. You get 3 over 5. If you're not sure, you can always use your calculator to help you check the answer. Negative 2 over 5 plus 1. Where does this 1 come from? It's a coefficient for this term. Okay, 3 over 5. And for the variable part, you just copy. How about B? Negative 2 over 5 x squared y z cubed minus x squared y z cubed. Again, if you're not sure, you always can press your calculator. Negative 2 over 5 minus 1. Minus 1. Negative 7 over 5. Okay, let me double check. Negative 2 over 5 minus 1. Yes, negative 7 over 5. For the variable part, we just copy x squared y z cubed. So you'll notice that for addition and subtraction, the variable part doesn't change anything. Just whole thing, you just need to copy it. Okay, now for multiplication. Negative 2 over 5 x squared y z cubed times x squared y z cubed. So for multiplication, you will notice that the power of the variable will change. Also, the same thing applies for division. Now, negative 2 over 5 times 1, you don't have to do anything, just copy negative 2 over 5. So x squared times x squared, you will get x power 4. How do I get 4? 2 plus 2. Y power 1 times y power 1, you get y power 2, 1 plus 1. Z power 6, 3 plus 3. Why do we plus them together? Because this is multiplication. Now let's go to the part D, division. Negative 2 over 5 x squared y z cubed divided by x squared y z cubed. So now again, if you're not familiar with this, you can just change it become this way. Negative 2 over 5 x squared y z cubed divided by x squared y z cubed. So these two are like terms, right? So when you divide them, you will notice that all the variable will just disappear. Now the answer only negative 2 over 5. Now let's try question number 5. Like terms or unlike terms. For like term, unlike terms, to determine whether these two terms are like term, unlike terms, only focus on the variable part x. Oh, unlike terms, y. This is x squared, different power. Unlike terms. These two terms are unlike terms. For unlike terms, we cannot perform addition or subtraction. we only can do this two part, multiplication and division. 5 over 3 x y squared z times negative 2 x squared y z cubed. Okay, so for the coefficient part, you can just use your calculator to help you. 5 over 3 times negative 2, you will get negative 10 over 3. X times x squared, x power 3, 1 plus 2. Y squared times y power 3, against 2 plus 1. How about that? 1 plus 3, you get 4. Okay, this is the way how we solve the multiplication between two algebraic terms. So how about division? 5 over 3x y squared z divided by negative 2x squared y z cubed. So just now, I showed this way, right? 5 over 3x y squared z over negative 2 x squared y z cubed, right? So this time, let me show you another way. You can just press your calculator, 5 over 3 divided by negative 2. Or if you want to show your step clearer, you can do it this way, 5 over 3 divided by negative 2. But in the exam, normally we do not show this step. For x part, this is 1, this is 2. It means 1 minus 2. For y part, this is 2, this is 1, 2 minus 1. Why? Because divide. That's why we use minus. For multiplication, we plus. So z, this is 1, this is 3, 1 minus 3. So this you can press your calculator, or if you want to do it manually, you can change become multiplication, right? And then it become, this is negative 2, right? 1. Become, maybe I write this way for you. Okay, correct, this one. No problem. X power negative 1, y power 1. 1, you don't have to write 1. Power 1, you don't have to write. Z power negative 2. So this one is 5 over negative 5 over 6. And this is 1 over x. This is 1 over z squared. And we have y over here. So if you are not familiar with this method, you can do it this way. Let me show you another way. Different method, but the step difference, but you're getting exactly the same answer. Now let me change it to this. Oh, sorry. 5 over 3 x y squared z over negative 2x squared y z cubed. Now again, for this part, you can just press your calculator. 5 over 3 divided by negative 2. You will get negative 5 over 6. As I told just now, when we want to simplify, right? Just cut the variable with the lower power. This is power 1, this is power 2, cut this one. And we have 1 left here. Okay, y squared, y power 1, cut this one. 2 minus 1, you get 1. Z power 1, Z power 3, cut this one. 3 minus 1, you will get 2. Okay, then you go through whole thing carefully. You have y here. And here you have x and z squared. Now, they get exactly the same answer. This is the way how we do division between two algebraic terms. Okay, let's try question number 6. Now, before I show you this question, before I explain to you how to solve this question, you have to understand this. X over 2 is actually the same thing as 1 over 2x, but difference is not equal to 1 over 2x, okay? And again, 3 over 5x is the same thing as 3x over 5, but it's not equal to 3 over 5x. You need to understand this first. Are these two terms like terms? As I told just now, this one you can change become 1 over 5 x y squared z power 4, right? Now, this and this exactly the same variable, same power. Therefore, these two are like terms, like terms. So for like term, we can perform all of this. X, y squared, z power 4 over 5 plus 5 over 2 x, y squared, z power 4. So as I told just now, this is just 1 over 5. You can press your calculator 1 over 5 plus 5 over 2. And for the variable part, for addition and subtraction is actually very easy. For the variable part, we don't have to change anything. We just copy all of it together with the power. The variable remain unchanged. The power of each variable remain unchanged as well. Now 1 over 5 plus 5 over 2. You just use a calculator to help you to get the answer. 1 over 5 plus 5 over 2. 27 over 10. 27 over 10. X, y squared, z power 4. Okay, so how about this one? Minus x, y squared, z power 4 over 5 minus 5 over 2 x, y squared, z power 4. Again, this is actually 1 over 5. And this one, we just copy 5 over 2. But in the exam, we don't have to show this step. You just press the calculator directly. 1 over 5 minus 5 over 2 and write the answer. It's okay. For the variable part, we don't have to change anything. Just copy 1 over 5 minus 5 over 2. Okay, you will get negative 23 over 10 x, y squared, z power 4. Now let's go to multiplication and division. X, y squared, z power 4 over 5 times 5 over 2 x, y squared, z power 4. Now, for multiplication, we can simplify this way, right? X times x is x squared. Y squared times y squared, y power 4. Z power 4 times z power 4, z power 8. Okay, and then we have 2 here. Okay, this is the answer for part C. Now let's move on to part D. X, y squared, z power 4 over 5 divided by 5 over 2 x, y squared, z power 4. Okay, but this one you need to be more careful. X, y squared, z power 4 over 5. Divide, you can change it become multiplication, right? I need to flip over the numerator and denominator. This is, so remember what I told you just now. Right in the middle is actually the same thing as right at the top. So you need to think this way. When you flip over, right, the numerator and denominator, this one will go down. 5xy squared z power 4 and 2 go up. Some students might make this mistake. They change it become multiplication, then flip over the 5 and 2, and this one they just copy. No, this is not correct. Okay. Now 2 don't have to, here is just 1, so 2 times 1 is still get 1. Sorry, 2 times 1 is equal to 2. 5 you get 25. Okay, now this is x, simplify them. This is x squared. This is z power 4, So the answer is 2 over 25. Let's try the last questions. Okay, are these two terms like terms or unlike terms? Now you know this is unlike term, right? Some students might think they are like term because x squared, y, z cube, but they are unlike terms. Why? Because this, right, is actually 2 over 5, x power negative 2, y power negative 1, and z power negative 3. So their power actually different. This is 2, this is negative 2. This is 1, this is negative 1. This is power 3, this is power negative 3. So these two are unlike terms. Unlike terms. So for unlike terms, we cannot perform addition or subtraction. We only can do multiplication and division. Negative 2 over 3, x squared y z cubed times 2 over 5, x squared y z cubed. Okay, so negative, positive, you get negative, 2, 2, you will get 4, 3, 5, 15. Now we can simplify that. X squared cancel up. This is also the same thing, and this is also the same thing. So eventually the answer is negative 4 over 15. Let's go to the last part, part D. So negative 2 over 3 x squared y z cubed divided by 2 over 5 x squared y z cubed. Okay, this one just copy first. Negative 2 over x, 2 over 3. X squared y z cubed. Divide, change, become multiply, and flip over the denominator and numerator. 5x squared y z cubed over 2. Now, 2 and 2, we can simplify them. Okay. Negative, positive, you get negative 5 over 3. X squared, you get x power 4. Y power 1, you get y power 2. And z power 3, you get z power 6. Okay, so for this lesson, I stop here. So if you want to test yourself, see how well you master this lesson or master this topic, you can download this file in the description box and try on your own. So remember, if you want to improve your math, right, do exercises is actually very important. If you watch my video, you do not practice, it's actually not effective at all. Okay, see you in the next lesson. Bye bye.